Assalamualaikum and a very good day to my panelists. Welcome to my final year project presentation. My name is Muhammad Haziq Hilmi bin Norazman and my title FYP is Flight Simulation of a Fixed Wing Multirotor Hybrid UAV for Crop Spraying on a Pineapple Plantation. I'm supervised by Professor TS Dr. Rizal Effendi bin Muhammad Nasir. So before I start with the introduction, I would like to present to you the summary of the project. The project is about a flight simulation of a fixed-wing multi-rotor hybrid UAV for crop spraying, and this hybrid UAV must have a long flight endurance and range for the pineapple plantation, where it can cover more than 2 acres of land. The project is focusing on simulation of hybrid UAV using a software, redesigning a certain part of the hybrid UAV and evaluate its flight performance and static and dynamics. Based on the given mission profile, mission requirements, and payload specification. With this project, it might help the local farmers in Malaysia to have a better technology for agriculture purpose. So let's move to the introduction, which consists literature review, problem statement, and objectives, scope and limitation. UAV is unmanned aerial vehicle which can be known as drone in public. Drone does not require the presence of a pilot or pilot on board to fly, and it can be controlled by pilot at the ground station or autonomously by flight plan that has been pre-programmed. Nowadays, drone increasingly becoming important in certain sector, including smart farming. By having drones in agriculture sector, it can reduce the labor expenses, time consumption, and other elements that can contribute to an increase in crop yields. Based on the observation that I had studied, fixed-wing hybrid drone has VTOL and can be extend the flight endurance. Hybrid drone is a good application for agriculture spraying compared to multi-rotor drone. Geometric and aerodynamics of hybrid drone has low drag and high lift coefficient to minimum the power required. The fixed-wing drone and hybrid drone have different endurance capabilities when it comes to flying. In certain article, Ventura Diaz and his colleagues discuss about the computational fluid dynamic CFD analysis of 3 different multi-rotor drones. The analysis of drones is done with different rotors and for various weather conditions. A comparative study is done for various configurations. Fixed wing can be optimized by changing the airfoil that used for wings, tail or stabilizer, and fuselage design to reduce the takeoff landing distance. The lift, drag, velocity, and various parameters need to be observed. Problem statement. The multi-rotor drone has the ability of vertical takeoff flight VTOL, which is ideal for activities that require a very slow speed cruise and hover, but it has a limited flight range and endurance. The area that can cover is between 1 and 2 acres. There is an option where we can use hybrid propulsion systems such as internal combustion electric or fuel cell electric propulsion to increase the endurance of the drones, but these systems are quite expensive. So there is another option that can be done, which is to combine a fixed-wing aircraft's relatively high aerodynamic efficiency with the VTOL capabilities of a multi-rotor drone, which resulting in a fixed-wing multi-rotor hybrid UAV. So this hybrid UAV cruises at a modest speed with high lift wing and limited multi-rotor lifting thrust. So in this study, a flight simulator is to be developed for such an aircraft using a software. The objectives of the project. First is to conduct the flight simulation of a fixed-wing multi-rotor hybrid UAV. Second is to evaluate the flight performance and static dynamics based on the simulation. And third is to redesign the landing gear, adjusting the angle of attack, angle of incidence at drone's wings, and horizontal stabilizer. Scope of the project is focusing on the simulation of a hybrid UAV, and this hybrid UAV has been modeled but not been optimized. As a result, it requires enhancement and recommendations such as redesigning the landing gear, the wings, as well as adjusting the angle of attack and angle of incidence. The simulation software is one of the research limitations, as it is a demo or beta version that I get from the supervisor, and I can conduct flight simulation within 10 minutes for every session. Now let's move to the methodology, which consists of process of research flow, the explain 9 flight simulation software, and explain PlaneMaker. So this is the process of research flow that I had done in this semester. To start the research, I have to do the literature review of studies regarding on analysis of hybrid drone, multi-rotor drone and fixed wing drone. After that, we move to the UAV design and specification. The initial design and selection of F1 is provided by my supervisor. So after the design and selection F1 is done, the hybrid drone is modeled using Explain PlanMaker. After that, the model hybrid drone can be run a flight simulation on Explain software. Lastly, the various data analysis can be acquired. Explain 9 is one of the flight simulator software that's certified by FAA, Federal Aviation Administration, where blade element theory is used in this software. Blade element theory in Explain involves breaking the aircraft down into many small elements and then finding the forces on each little element many times per second. So basically, this technical theory is completely transparent to the end user. Explain PlanMaker is one of the applications included in Explain software where aircraft or drones can be developed with specific data given. The important data that needed for such an aircraft is fuselage design, wings, horizontal and vertical stabilizer or tail of the drones, engine spec for propellers, landing gears, and weight and balance. As you can see, the picture at the left side is design of the hybrid drone in wireframe form, and picture at the right side is the F1 of stabilizer and wings that used in hybrid drone. Next, we move to the preliminary result. For the preliminary result, I will show you the short video of flight simulation that I had conducted, and then the flight simulation data from the flight simulation. So this is the result of one of flight simulation that I had conducted. It shows lots of various data that I can get from the flight simulation, and this result is manipulated variable where it depends on how the user control or fly the craft or the drones. The constant variable in this result is the fuel, the weight of the drone, and the payload. So I took 20 variables data that the hybrid drone is in flight. For the blue indicator, it shows the speeds of the drones, but the speed is in knots, while for the green indicator also show the speed of the drones but in miles per hour. And after that, the Mach ratio is the ratio to Mach 1, and alpha is the angle of attack of the drone in degree, and beta is the angle of side slip of the drone in degree. And this is the result from the 20 data regarding of the engine of the propeller. And as you can see here, it has 4 power here, because each propeller has their own power, and the thrust also got 4 for each propeller and RPM for each propeller. So last but not least, this is my project planning for this semester. This current semester, I had done with the FYP briefing, the title selection, the literature review, studies on the analysis of hybrid drone, fixed wing drone, multi-rotor drones. And after that, I had done with exploring the Explain flight simulator, including Explain PlanMaker and how to control flight for the flight simulation. And after that, proposals, preparation and presentation. And last for this semester is submission of proposal. Okay, so for the next semester for FYP2, now this is just the project planning. First, I've been told that next semester we are going to do the concepts of the hybrid drone. So maybe the first activities that I need to do is the analysis of hybrid drone, and then the 3D printing of the concept of hybrid drone. And after that, the discussion and recommendation, including the conclusion for the thesis, and thesis preparation and submission, and for the final is the final presentation. So I think that's all from me. Thank you.